Probably the more interesting ones, though, however, all these multivariates. And the multivariates being quite a bit more interesting from the sense of there is no CMDB backing the service models. There is no relationships having to be maintained. The system is computing all of this from a mathematical relationship between KPIs that are doing interesting things at the same time together. So what Predictive Insights does under the covers is it automatically builds these relationships between the metrics and what normal is for those metrics as they track to each other. And when things go abnormal, it also takes a look at those relationships to see whether or not all of the particular relationships are working in a similar abnormal fashion. And what it does, it gives us the opportunity to put those together into one view. So we can kind of get a feel for what might be potentially going on across those. So in this particular case, we're going to look at this one here, which is a related event that's a consolidation on two different metrics that occurred. And you can jump in and look at child alarms. And so you can look at the two original events that make up, or the two univariate events that would normally make up that particular group. Or you can just plot directly from the multivariate right to the service diagnosis to show both metrics at the same time, which is often more interesting. And so what we got here is we have a SAN where we've got two resources, the SCSI disk A and this LUN disk 7. One is getting a pull hit ratio degradation, and one is getting a response time anomaly, both at the same time. And so the system has determined over their pattern of life that these things do have some type of interesting relationship. Because as you can see here, every time one goes down, the other one goes up. So every time we have a pull hit ratio that is dropping, we also see that our response time on the other particular LUN is going up. And it's not something that's happened just once in this particular case. It's happened several times. So the system is knowing to start tracking these particular KPIs together as a relationship. And we can turn on a baseline for one of them and kind of get a feel for where that particular metric normally would have its baseline calculations for. But again, here, later on, we had another crossing where, again, what we see as this one is going down, this one is going up. And so every time we see pull hit ratios decreasing, we see response time increasing. And vice versa when they come out of that situation. And they reverse back to kind of a normal standard. And in this particular case, when it hit the final kind of large problem anomaly here, both of these particular things were out of their deviation in a way where the system said, okay, this is going to be something we need to throw an event on. And, this particular one, it stayed in that situation for about an hour and 5 minutes, it looks like. And normally, they would have been looking at just one performance metric, or people would be looking at one performance metric for maybe, the SCSI disk that's sitting on the physical server or the logical server, and not really looking at the SAN LUNs that are supporting that. But by being able to draw the correlation between the mathematical correlation that these things occur at the same time, we're able to really draw a conclusionary anomaly that these two are related and they do affect each other. And it gives you a pretty pinpoint thing to look at one or the other as potentially being the root cause of what might be driving this anomalous behavior. So the mean time to detect and the mean time to repair typically go down when you can draw these kind of correlations and get people looking at the right thing sooner, versus kind of running around and figuring out what is linked to what from a CMDB or a service model perspective. Nothing was fed into this particular system to give it any kind of hint that these two things are related. Every metric is associated with every other metric and in an analysis perspective to determine if the two do have any relationship, and if those two have relationships, are they something that when one does go anomalous, the other one always goes anomalous with it. And so this is a good example of the power of PI's multivariate analysis, which very few tools in the market really work across. I think there are quite a few tools that are good at single variate metrics, but I think when you get into the univariate experience, you really are finding more interesting things than you could find with traditional performance or traditional even analytic tools in the market. And so I think that this is, in this particular case, I'm trying to think of I think the root cause of this one might have been a misconfiguration on an HBA, and they ended up correcting it on the SAN side and fixed the anomalous behavior. But just like with the univariates, we can turn on potentially, the forecast metrics for these, and say, if you wanted to turn them on, I think it might draw them. I'm not sure if my screen's wide enough or not, though. Here. Yeah. So again, with the, it doesn't look like it's going to be coming outside of the anomalous state anytime soon, since they're both kind of tracking still in the lower ranges, and it expects that it's going to be in that same anomalous behavior for at least another couple of hours based upon the mathematical prediction. So it is probably something worth somebody taking a look at pretty quickly, so you can stop your users from experiencing maybe potentially slow applications or slow response times from their server, or from things going on that this particular set of disks and LUNs are associated with.